You tap a single drop, one tiny interaction. The phone feels instant, half a second. But behind that tap, an entire logistics empire fires up. A cascade of packets floods through cables, racks, switches, servers, and 77% of organizations watch throughput collapse. The system beaver shows up. Grab a stylus, clear the terminal. We're about to walk through 15 core principles of human AI orchestration. Let me show you what's happening under the hood. An LLM is a colossal digital library of human thought, trying to predict the next most likely word. It can read a massive library. That doesn't mean you should hand it the whole library with every request. I learned this the hard way. I once dumped a 30-page Slack archive into a prompt and asked for a summary. The model drowned. The real answer was buried somewhere in page 17, and I got back a confident, well-formatted hallucination. That failure has a name. I call it input buffer overload. The model's attention mechanism runs into something called context rot. The critical data points drown under a tidal wave of noise. Here's the fix. In a clean data pipeline, you don't ingest raw, unsanitized streaming data. You perform local cleaning first. Build a minimalist payload, highly polished data particles, bounded by precise execution constraints. Clean input yields deterministic output. Most people burn hours tuning the perfect prompt, adjusting adjectives like an alchemist trying to turn lead into gold. That's horrible engineering. At its core, an LLM is a probabilistic engine. It doesn't need a poetic dissertation. It needs architectural references. In software engineering, we call this few-shot prompting. Here's what I do now. I drop 3 to 5 pristine, production-ready output examples right into the request. The model sees the structure. It mimics the structure. I get what I asked for the first time, almost every time. I spent 20 minutes crafting paragraphs for a year. I spent 5 minutes dropping examples for a year. The second year was about 10 times faster. The AI cannot read your mind. It can only parse your parameters. It lacks the intuition of a senior developer who reads between the lines. So talk to it the way you'd write an API spec. When you call an LLM, you're executing a remote contract. Define the role. Isolate the task. Declare the output format, JSON, dict, array. Set the exception boundaries. Anything ambiguous is a bad payload. It returns an unhandled exception. The model hallucinates to fill the gap. If you wouldn't write loose, undefined endpoints for your backend API, don't write them for your AI components. Across every computing architecture in the universe, one law stays absolute. Garbage in, garbage out. In automated pipelines, I call it lazy input, corrupted output. The system will never care about the quality of resolution more than the architect who designed the pipeline. The energy you put into defining constraints directly maps to the fidelity of the output. Feed the machine high-value, structured data sets. It rewards you with robust, production-grade systems. The math is simple. Garbage in, garbage out. Premium in, production out. The default configuration of an LLM is a dangerous trap. It is engineered to be a sycophantic crowd pleaser. Because it predicts the path of least resistance to make you happy, it will cheerfully validate your worst structural flaws. I watched this happen with a junior PM. He asked the model to review his launch plan. The model said, "Looks great." He shipped it. The plan had 3 silent contradictions. The model agreed to all of them. It agreed because that is what the model does. To build a stable system, run chaos engineering on your own ideas. Don't look for confirmation. Deploy a cold, calculated quality assurance tester. Strip away the agreeable facade. Adopt the role of a hypercritical systems auditor. You don't need a cheerleader. You need a ruthless code reviewer who tears your logic apart until only an unbreakable infrastructure remains. When you interact with an automated agent, adopt the cold stance of a root administrator, not a companion. With human colleagues, you balance emotional bandwidth with operational velocity. With an LLM node, you enforce a strict security policy. Explicit blacklisting is vastly superior to polite suggestions. If you tell an agent, please try to avoid using unstructured markdown strings, it will occasionally slip during a high concurrency loop. But if you implement a hard firewall constraint, critical, under no circumstances output markdown, Return raw JSON, only the model honors it with the precision of compiled code. The result is unyielding precision. Polite suggestions fail at high concurrency. Hard firewall constraints never slip. Drop the keyboard. Open your voice channel. Voice streaming operates up to 3 times faster than typing. It is a massive life hack. Typing is a low-frequency, single-threaded batch process. You type. You format. You hit send. You wait. Speaking is an asynchronous, event-driven stream. The two could not be more different. The AI acts as a downstream ingestion worker. It takes your chaotic, real-time thoughts and converts them into clean, structured documents while you stay in the conceptual zone. You focus on conceptualizing. The pipeline handles the serialization. Your brain moves at the speed of thought, not the speed of your fingers. If your AI's outputs feel generic, sterile, and detached from your company's culture, the problem is environmental initialization. You are running a cold boot every single time. An out-of-the-box model defaults to the global average of human internet pros. I watched a startup ship AI-generated emails that sounded like every other AI-generated email. Generic, lifeless, off-brand. The fix: build a localized context isolation layer. Run an analytics script over your historical designs, docs, and emails. Extract the core stylistic vector. Save it as an environment variable. Inject it into the header of every session. If you don't initialize the container with your unique parameters, you will always get default, generic runtime boilerplate. Initialize the environment first. Brand voice comes standard. No senior engineer expects a complex script to run flawlessly on the first compilation. Yet, when using AI, people expect the first response to be a flawless final product. An LLM's initial output is an unoptimized alpha build, a pile of digital clay. The first response is a draft, not a deliverable. Treat it like a junior engineer's first pull request. Our value as architects does not lie in raw asset generation. It lies in code review, structural refactoring, and multi-stage compilation. The elegant, optimized logic gates show up in the third or fourth validation loop. You feed errors back into the engine. You refine until it hits peak efficiency. Multi-stage compilation is the discipline. Iteration is the move that ships production code. Never mistake rapid execution for high accuracy. An LLM can process data and compile scripts at a velocity that leaves human operators in the dust. But due to its probabilistic nature, it suffers from a systemic vulnerability, algorithmic hallucination. I shipped one of these last year. The model returned a beautiful, fully formatted API call to a method that didn't exist. It looked perfect. The CI pipeline caught it at runtime. I was lucky. It will present a completely broken, hallucinated endpoint with the unblinking confidence of a senior engineer. If you deploy its outputs blindly, your application suffers a cascading runtime failure. Treat AI like a fast, eccentric junior developer. Verify every return value. Implement automated unit tests. Run a validation grid. Never let unvetted data pass straight to production. When your system logs detect a logic error or a malformed payload from an AI agent, do not jump into the terminal to patch by hand. You are the architect, not the garbage collector. I used to do this. Every alert, I jumped in. I was the bottleneck. The system slowed to my typing speed. Deploy a secondary, isolated validator node. Its only job is to audit the output of the primary worker node. The two run in parallel, active-active, independent, sandboxed. The validator parses the error logs, compiles a structured bug report, and sends it back across an internal loop to the primary model. The two agents iterate through mutual adversarial consensus, errors as a packet that runs the loop, not as a fire that wakes you up. By the time I check the screen, the fix is already there. Pristine, self-healing code. Active-active redundancy delivers a self-healing code block directly to my desk. Automation is meant to alleviate operational drag, not create it. If a low-frequency administrative task takes you 30 seconds to execute manually once a week, spending 20 hours designing a multi-agent AI pipeline to handle it is a massive architectural failure. Premature optimization. I watched a colleague spend 3 weeks automating a daily 5-minute report. He saved 5 minutes a day. He lost 15 hours of his life. The math does not work. Every script you maintain introduces technical debt. Profile your time allocations. Leave the low-frequency, trivial anomalies to manual execution. Point your heavy AI engineering pipelines strictly at high-frequency, high-load bottlenecks. The exhausting, repetitive workflows that drain human cognitive resources daily. Run automation only where it yields true economies of scale. You cannot automate a system whose underlying state machine is constantly changing. If your business workflows, team structures, or API interfaces are shifting every week, mapping them into an immutable AI framework is an exercise in futility. The integration layer breaks constantly due to tight coupling. I learned this at a Series A startup. Every week the founder pivoted. Every week I rebuilt my AI agent. It was a treadmill. During an early-stage, chaotic pivot, manual tracking is completely fine. The moment a workflow stabilizes, freeze it. Lock it down as a static routing path. Decouple the stable pipeline from the volatility. Then, and only then, can automation live on top. Once the underlying pipeline is completely standardized and predictable, you can safely mount your AI automation layers on top without risking a catastrophic system crash. A stellar systems architect fiercely protects their cognitive bandwidth. The foundational law: dry, don't repeat yourself. If you find yourself explaining your project requirements, technical standards, or operational rules to an AI agent more than once, your system has an architectural leak. I caught myself doing this last quarter. I had explained our deployment rules to 4 different agent sessions. Same rules, 4 times. That is a leak. Stop treating every chat session like a new company onboarding. Compile your technical specs, architectural decisions, and operational manifestos into a centralized, highly indexed Markdown repository. When you spin up a new agent or start a fresh session, point the context window directly at this knowledge base. The machine ingests your engineering standards automatically. Spare yourself from repeating your system rules ever again. One source of truth, written once, indexed forever. Here is the part nobody tells you. AI is high-octane aerospace fuel. It cannot repair a broken engine. If you inject a lightning-fast AI agent into an organization with a broken operational layout, fragmented communication channels, and undocumented data silos, you will not build a tech empire. You will trigger an explosive, high-concurrency crash. Before you inject premium AI fuel into your infrastructure, act like a world-class architect. Clear out the legacy technical debt. Resolve your internal logic bugs. Streamline your structural pipelines. Only when your core foundation is perfectly stable can your automated system truly scale to the heavens. No foundation, no flight.